In this unit, we've discussed sampling distributions. We first saw that a sample statistic, like a sample mean, a sample standard deviation, or sample proportion, can vary from sample to sample depending on how that sample happened to have been drawn. And those sample statistics may be very different from the parameters of the population from which the sample was drawn. As it turns out, the sample statistic is a random variable itself. A random variable can take on several realizations, each with a likelihood of occurring. And that's what we see with, for example, a sample mean. Depending on how the sample was taken, we could have several different realizations of the sample mean. Some of those realizations are more frequent than others, hence a likelihood of occurring for each one. The distribution of the sample statistic random variable is called the sampling distribution. Some things that we know about the sampling distribution for the sample mean. We know that the mean of the sampling distribution is the same as the mean of the population, mu, and the standard deviation of the sampling distribution is sigma divided by root n, where sigma is that familiar parameter of the population from which the sample was drawn. Sampling standard deviation, sigma over root n, implies that the larger the sample, the more tightly dispersed the distribution of the sample means will be around mu. And that should make intuitive sense. The larger the sample we collect, the less variability we'll see in our sample means.